Yeah. What do you think today's date is?
That's
The 11th?
I think it's the 11th. The 11th, yep.
Yeah,
okay,
that's
11th.
Let's see. Yeah, 11th. Okay, good. Now let's do the ORP first. I do the reduction potential.
What is that?
Which? This is a camera.
Okay.
So I'll just keep that there. Keep this puppy here. This is what the probes are. I'm an old man, you know. So now turn it on. Oh, this is the pH. Sorry.
What's that here? What do you need?
Huh? It will tell you whether it's acidic or basic, you know. The first time doing the ORP.
That's pretty cool.
You know what is acidic?
Huh?
You know what it means by when it's acidic?
Nah.
It's like, have you got battery acid on your hand by any chance?
What?
Have you ever got battery acid on your hand?
Yeah.
It burns.
A little bit.
Yeah, then vinegar is acidic.
Okay.
Yeah.
Because how much acid inside here?
Hmm?
Because how much acid is inside?
Whether it's basic or acidic. Like soap is base, it slips.
What's a good pH level then?
Huh?
What's a good pH level?
A good pH level is around 7. Neutral is 7.
7?
Yeah. Then acidic is below 7.
Okay.
More you go below 7, more acidic it is. And more you go over 7, the more basic it is. So can't see anything here. Okay.
It says it is 165.
Yeah, negative 165.
Yeah. 166.
166, 107. So it's anoxic. If it's positive, more positivity is, more oxic it is.
Okay.
Oh shoot! Oh shoot! The boat.
Oh yeah.
Oh.
What is that then? Tells you acid, huh?
Huh?
Tells you the acid inside here?
No, this is whether it will tell you if it's anoxic or oxic. Now, let's say your garbage, when it starts stinking, it's anoxic, you know. So negative 167 and 24.6 degrees Celsius. So that's your temperature, 24.6, negative 168. Okay, we go with negative 168. Let's see what that says.
pH level's at 8. It's rising.
Yeah, let's see. So 8.27.
It's rising.
Mm-hmm. 8.42. You know what? Have you been to Turtle Mountain School?
Yep.
8.46. So it's staying at 8.46, 8.47. No, it's always alkaline here. This all the soil is alkaline. So 8.48. So because the soil is alkaline, the water is also alkaline.
Okay.
So this is 8.48. And the temperature is 24.8 Celsius.
Okay.
See, in science and all they use Celsius, they don't use Fahrenheit, you know, like yeah. So the temperature.
How come you don't use Fahrenheit?
Because it's so complicated. Because between 1 and 100 is water freezes at 0 Celsius and boils at 100. Whereas in the Fahrenheit scale, it's 212 and 32. Okay. So it's hard, you know. Yeah.
Celsius?
Yes, Celsius is easier. So we have 8.48. That's good. And then now the total dissolved solid. This will tell you how much. Now see, if you take water and slowly add salt and into it,
Yeah.
then slowly, the total dissolved solid, which is salt. More salt you add, the more.
This tells you how much salt in it then?
Yeah. So, but the normal salt we use is sodium chloride. That's not the salt. I mean, if it's in the sea, yeah, it will be mostly sodium chloride. But in this part, it's not sodium chloride. So it's 417. Yeah, 417 parts per million. 418. 420. Okay, good.
Is it good then?
Yeah. No, I mean, good that you finished it.
Was it good? The water treatment?
This will just, I mean, if it's like 2,000, 3,000, then it's very hard to drink that water.
What is the water right now?
This is 412.
Oh, wow.
So, yeah.
Can't drink it at all.
No, if it's like 2,000, 3,000, then you can't, then it's going to taste salty and you get very thirsty. If it's like 5,000, you can't drink it. Because if you drink that water, you'll be discharging more water.
Okay.
And you get thirsty and thirsty and thirsty. So, this is the Red River and this is Evan. And, yeah, there's down, this is upstream. No, this is upstream. Upstream is over there. And this is downstream. So, now